it did not
Hmm.
in this case.
Yeah.
Then Anthony said that the software is the most reliable way of looking at your results, because basically we had to go back through all the samples and gate them manually,
Hmm.
because we just didn't have enough beads, which I'll go into all our issues and solutions that we talked about.
Yeah.
So you mean this time you and Anthony had to do it?
Yes, Anthony and I had it, surprisingly, which isn't that surprising.
No, it's not surprising because that's what we did. That's what
It
we concluded.
actually, yeah, we actually had better results when David and I did it than I did with Anthony.
Right.
So basically how this works though is it gates on the A and B beads and then goes through and gates on all these peaks, which are the cytokine bead populations. So the software does it automatically in the spots it's supposed to, but you see how there's these little baby peaks here?
Yeah.
That shouldn't be there. That's because we didn't have a large enough bead population, because this panel here is pulling from the B beads, and look at how few B beads we have.
So why are there so few beads?
So there's multiple things that we think it could be. Let me share with you the.
So Catherine, before you go, so what are the sample you have and then the assay you had? Kind of briefly go through.
But wait, can I just, before you do that, let me just say this. You know, if you go back to your thing you just were showing, your histograms.
Uh-huh.
Can you go back to that?
Yes, I will. Can get out. Escape my share.
What's going on?
I can't escape the share.
Really? Let's see.
Oh, there we go.
There you go. Okay, so go back to the histogram thing you were just showing. Yeah, okay. So the thing is this looks like it's done, I see from the top, LegendPlex software.
Right.
And so, of course, we agree that this is the right one to do, right way to do it. And then we don't want to just, like, as you have underlined there, review gating. We want to move things around, you know, we think.
Right. So that's what we did. This is not how, so I analyzed this with Anthony yesterday, and it did not look like this. We had.
Right. Okay. No, I understand. Okay. So that's what I'm
down
getting
here.
to. The point is that when you first did this, we looked at this, used this crummy software, and they didn't even allow us to do this. I don't even think I saw this. We said, well, there's peaks down somewhere in here. It just gave a bunch of numbers that were inaccurate. And so we said, well, what does it really look like? So that's why we resorted to drawing it a manual way. And we didn't know that their program, what do you click on to get to this? Because I remember this was not there. Even their incorrectly identified peaks, we didn't see that the first time.
So last time I couldn't get the software to let me go to review gating. So it just would go straight from samples, gating automatically, and then just give me results.
I see. So how do you go? So how can you go to review gating?
So
I know it just says demo 8.1.21. Why is it a demo?
Because, well, we called this the demo because that's what Anthony knows. So
the software isn't the demo, the sample's the demo.
No, so basically when I went to run gating, it gives you, which I can't show you now because it's already done, but when I went to run gating, it gave me an option to stamp the gating onto all the gates, and then gave me an option here for review. So then when I click review, I can see all the samples.
So why can you do it now when you couldn't do it before?
I just didn't know where the button was. There was a button at the bottom saying stamp gating, and I didn't know what that meant, so I didn't do it. It's not in the instructions to do that. I was just following the instructions for the software that's on their website because I didn't know how to use any of it.
All right, I understand. Okay, so
So he showed me to
sample
do that. You want to
sample
stamp the
dating at the
dating,
bottom. All right, I understand.
and then I can go through all of them like this, and then we adjusted all the gates from there.
Can you move them around now? Can you show me a sample? Like B2 up there? Can you click on that and move that little thing around? Oh, there you go. Yeah, all right.
So I
Okay.
can move
There you
it,
go. Right,
I
okay,
see.
stuff like that, save.
right, okay.
So,
All right, that's all. I was just wanting to know what's different now than
yeah, no
then.
problem. Yeah,
So, I
so,
mean, this is what we wanted to begin
right.
with. If we
And
did,
it's nice because now I know how to adjust it correctly. I know, what all these things like this actually comes up. Now I know where the numbers are coming from when you go to results. You
can
know,
you go back again to this thing, the other thing, the histogram deal? So here's the thing. I noticed you gate on the A and the B beads.
Yeah.
And N is 6, N, I guess, the number of beads. I mean, why, 646, 462 versus 60? Why not have like 10,000 and be accurate? Why do you have to have like just a few hundred beads or even less than 100?
well, I think it's just a problem with bead recovery, and I can talk about that quick.
I mean,
Basically,
did you vortex a sample, and how could there be a problem with bead recovery? Aren't there millions of beads?
yeah, so the low bead yield we think is due to possibly
Oh, leave those.
losing the beads. So originally I would flick the plate. It says on the instructions, it says like vigorously like shake out super knit from plate or something after the washes. So that's what I was doing, like in ELISA kind of, you flick the plate until everything's gone. Anthony said not to do that. Instead, just pipette out the super knit so that we're not losing any beads, because that could have contributed to the low bead yield.
But
Yeah,
what about if you put more beads in to begin with?
I don't know. He
I mean,
didn't.
how many beads do you put in to begin with?
We put in 25 microliters.
So how many beads is that?
I don't know. It doesn't give us a concentration of beads in the bead mix. It just gives you the mix of beads.
so, yeah, so you did it previously. That wasn't an issue, right?
No. So the
Right.
other thing could be is that that it was due to the plate reader, which is likely what it is due to. So Anthony encouraged us to use the plate reader for the demo because he was saying that since it's a assay done in a plate and we have the option to use the plate reader on the Symphony, that we should just use the plate reader, because then you're getting rid of the human error of me pipetting all 100 something samples into the tubes and doing it that way. But the issue was when we went to use the plate reader, there was an issue with the plate reader. So my plate sat for a while.
Yeah.
And then it wasn't vortex or anything. And then additionally, the plate sat there and went through every well. And you can see that the samples that got read first have higher bead yield than the other ones. So what's happening is the beads definitely settled to the bottom. And we didn't take the whole volume. We only took 70 microliters. And we had 150. So what happened is we definitely didn't get as many beads because they were settled to the bottom at that point.
Now, the same thing happens to cells. So this is the problem. But the thing is, I thought that the Symphony, because everybody knows this with the plate. So I thought the Symphony had a way. I thought what it did, the probe went in and then it sort of aspirated and injected it. So it stirred up the thing, because it can't shake it.
Yeah.
So it was a probe, like up and down pipetting.
Yeah.
That can probably be set. Sagar could set this for more times, more vigorous, vigorous high, set high, and then sample volume set, to instead of 70, you can set it to more,
Yeah, I'm not sure. It was actually Sagar who said that's probably what happened, that the beads were settled to the bottom.
Yeah.
I think it's probably because we weren't taking the whole volume. Maybe it was mixing up and down some, but taking half the volume, mixing up and down. I'm not sure. I also am not sure if that even was the setting that he put it on. or not. I've never used a plate reader, so I didn't really know anything about it.
I'm not familiar with it
set
either,
it up.
but I imagine since this is a problem with cells,
Yeah,
the same problem, that there's a way to,
yeah,
your cells are not bigger and they settle faster, then you set the up and down thing to have higher velocity, many more times, because it does too many times, then it takes time. So any event, but it's worth it. So besides, it doesn't matter because that sample is what we're worried about. So
right.
that's one thing. And then take more volume. I don't know if it's good to, I guess it doesn't matter. I'm thinking of all the beads at the bottom. But whether it matters to go dip into beads. You normally don't dip into clumps of cells that are at the bottom, because then you just get clogged.
Mhm.
But I don't know if beads will clog. But in any event, I think the Symphony probably has adjustments to make a more vigorous resuspension per well.
Okay, yeah, I think we kind of decided to just pipette everything into tubes so that we can vortex right before and know that it'll work better, because
Right, like
I
cells,
think
put it
that
into
definitely, yeah, it definitely made a difference
Yeah.
on bead yield, because we actually ended up, so I ran 2 demos. The first one, there was literally like no beads. And that was definitely because of the vortex shaker that we made up. So because we don't have a normal plate shaker, Anthony was like, oh, we can tape the plate to the top of a vortex and then have it set at a lower speed so that it's kind of mixing more than what the mixer behind Chang Ming's desk looks like, where it just goes back and forth like
No,
this.
that won't mix at all.
So I used the vortex shaker, and what happened is we got no bead yield, and it's because we didn't when we redid the demo, Anthony did his plate doing everything the same but with the vortex shaker, and I used the plate shaker behind Chang Ming's desk, and his beads were not coded correctly. It would be the detection antibody coded half the bead instead of the full bead. So we got 2 weird populations for every one population. And he said that
Mean
shows
like they
that
spilled into each other.
basically it was vortexing instead of shaking. And therefore the beads didn't get fully coated all the way around. They got partial coating of the detection antibody. So he was like, yeah, that vortex shaker won't work. So we kind of need to find a lab. I was going to ask around and find a lab that has just a normal plate shaker, because we need one, I think, to make this experiment get the proper bead yield. I tried the one behind Chang Ming's desk works okay. I switched the direction, so it would be the plate would be going this way for a bit, and then I would switch the direction so that it was getting all around the wells, instead of just back and forth in the well. I don't know what else I can do for it. We don't really have any other option for that. But Anthony said that that's likely why we have low bead yield as well.
Well, settling's always a problem, and lack of mixing. That's the number. In fact, I think that's the number one problem in science. That and labeling badly. Those 2 things cause all the errors in science. So we have to think about it for a second. A V bottom plate makes me worry a little more, because then it's even worse. It's in a V bottom plate.
Yeah,
right?
it is, because we either have to use a V bottom plate or have or use the filter plate, but then we don't have a vacuum system for filter plate.
I might just buy one. It's not that expensive. Here is a 4 plate shakers, and it's $660. This is not with the UAB price, so might have even further discount.
Okay.
Yeah, but how does it shake? Is it?
Well, so
it's hard to agitate to shake that in the right way. Going back and forth will do essentially nothing. This is good. What this is good for is if you have a flat surface and you're washing liquid over a gel, for example.
I see what you're saying.
That's the only thing it's good
The V
for.
bottom plate, it's not moving a lot.
It won't move at all. I mean, that's a vertical problem.
Yeah.
It only works if you have a horizontal problem. For a vertical problem, you got to have vertical forces, such as pipetting up and down. So I don't know. We have to look into the settling problem. I don't like the idea of having to just vortex up and down, but or take each one out. But I suppose that's, you go up, you want to get it. How many microliters is it?
The total volume in each well is 75 microliters.
Yeah, so you get the P75, P100, set it for 80 or something. Don't make bubbles, I guess, and just go up and down a few times and then transfer it to a tube. Be careful.
Right. That's what I will do. The issue is with the plate shaker is there's 3 incubation steps. So the first one is the sample and the beads, and that's 2 hours. And then it's the sample, the beads, and the detection antibody for an hour. And then it's PE for 30 minutes. And during all of those steps, it's supposed to be on the plate shaker. So if it's not getting really,
they all need to be
then that would be a problem.
right. Every one of those needs mixing.
Yeah.
So I was just thinking of something, and 75 microliters is a bit of a problem too, because the Symphony isn't used to 75 microliters.
Well, it's 150 microliters when I resuspend and wash buffer. Basically, I pellet after adding PE and letting the plate sit for 30 minutes on the shaker. Then I pellet the whatever's left in the.
But even 150 is kind of low for the Symphony. Usually people come in with like a mil of liquid, and they suck off the top if they need to, all but the last 100. You're starting where most people stop.
I think 150 is okay, because we did the cells bags with the plate. I think that's about 150.
Okay.
Well, that's true. The plate is a maximum of 200, so 150 for the plate ought to be okay if you can agitate the plate.
Yeah, I see.
I think the plate is obviously the best thing, but you have to mix it properly. I was wondering about when we do PCR, we put this plastic cover on the plate and seal it. And then supposedly the reaction's contained within each well. And we do that because I guess we're worried the steam or something during boiling will float over to the other, even though there's a big pressure thing on top, which we might need. We might need to put seal it and then put a big pressure thing on it, like clamp it between 2 rubber pieces.
I did use plate sealers in all the steps.
Oh, you did? Right. So that would be, then you could vibrate up and down very quickly and then test it to make sure, see if that.
The thing is maybe after all is done, if the V is the problem, is the V button the problem, that we thought it might be hard for maybe right before you run the fax, you transfer everything into the U button. Would that help?
I don't know. The thing was even with the plate reader in general, I guess that if, for instance, something doesn't read, we had that happen when I ran the demo on the plate reader. There was a well where it took up my sample, but then it didn't give me any data back for it. And that happens sometimes. We asked Sagar and I think it's Raul about that because they both use a plate reader often. And they said that does happen. But Sagar said that for my actual experiment, he would suggest that I use the tubes because then if something goes wrong, I get the sample back. He said if it gets taken up from my plate reader or from the plate, if I use the plate reader, if the sample gets taken and something goes wrong, the sample is gone and I cannot.
Right, that's right.
So he was saying it's less risky and it'll take longer for me to put everything in the tubes.
Yeah.
But that it would be less risky to just put it in the tubes than to try to do the plate reading.
Yeah, then it's not the automatic. You gotta do it manually, but we won't lose anything.
Yeah.
Sagar probably didn't consider, he probably was doing 2 other things at the same time. So, you know, he didn't have a chance to think it all through, but we can talk to him. Now, what Wei Chin just said actually is a stroke of genius. You know, she does it every now and then. You know, take a 12-channel pipette and put all the pipette tips on it very good. You go up and down very much in a V bottom plate. So you got everything very carefully. I'm covering it very carefully. And then everything's there, and then transfer it to a U bottom plate. I like that a lot because all of a sudden they're not down there in the corner. They're at least in a rounded area. And it seems like that's got a better chance of actually being resuspended. I mean, it's impossible to get things in a V bottom plate to move. They're stuck down in the corner down there.
The thing is, though, if we do that, I think, because I was talking about, I forget what I was talking about, transferring everything into something else. And Anthony was like, well, every time you transfer from one thing to another, you're going to be losing beads. So if we did that, for instance, and we had to pellet it after every step, and I had to move it into a round or flat bottom.
No, that's not right. Anthony has apparently trouble thinking. You take the 12-channel thing and stick it in there. Say there's 150 microliters, or maybe 100, whatever. Put the 12-channel thing very carefully in there. Go up and down, resuspend everything, and then you get everything but a little bit of liquid left. Then you do the same. You get a little buffer on the side and do 15 or 20 microliters and put that in. Go up and down and wash it once, and then put that back. So you do it twice. I mean, these things are all worked. These things can all be worked out. You will not lose any beads if you do it right. And it has a better chance of being, that's not the problem. The problem is it's not losing beads. The problem is they don't suspend at every step in a V-bottom plate. I guess you have to use their V-bottom plate to begin with because you actually don't want, is that right? Yeah, the volume is very small. So you want everything. It's like a nuclear reaction. You want all the nuclei close together to have a reaction. But you don't want to be like, but you don't want that to go on forever. So when you wash, you want to respin. And when you do subsequent steps, I guess in some cases, but definitely when you read it out, you don't want them to be all stuck, all at one spot and all, you know, the probe goes down, the beads are all down here, and the probe never doesn't even see it.
That's what we think happened, yeah.
Yeah. So what Wei Chin said is the way to go. Now, if you want to get all the beads, you do a wash step, like we do with many things. You do once, and then you have a separate pool of liquid over here, you know, like a 96 well plate with a separate bunch of little wash buffer. And you take the first row and you wash the first row here with that. And then you go up and down, and then you transfer that to the second plate. So you got 3 plates. And then you do the same thing for the second row.
Okay.
That's the way to do it. I guarantee.
Okay.
If everything else, of all the other things we talk about here, that is the way to measure it. It's evenly in symphony. And the second thing, of course, when you get it to the symphony, is to because get Saga when he's not doing 2 other things, and tell him, okay, we want to adjust this thing so it definitely resuspends. And of course, test it so that it does resuspend each well as you go. It'll solve everything, make it easy, it'd be uniform. Won't lose beads.
And then the other thing is, if we want to do that, then I will probably need to ask David to order some of the BioLegend flat bottom plates, because we realized that, for instance, the V bottom plates that we have in the lab had I think polycystine plastic or something like that, that Anthony said would make the beads stick to it so that they wouldn't suspend as well in the samples. So there's specific plastic that we need to use.
Well, they're usually polystyrene or polypropylene. Is it a third?
Polystyrene is what I was thinking of that we need. Polystyrene.
So what is his plates? Polypropylene?
I think so. David knows for sure what they actually, I think David was the one that thought of that. I had no idea. But he thought about it and checked the reference number of the V bottom plates that we were using, that we had in the lab. And then they had said that would make an issue with recovering beads.
Well, this comes up a lot. This comes up all the time. There's also low adherence plates. And So you can probably get V-bottom low adherence plates, and I don't know what they coat them with, but you know.
That's what we have now. We got more, Anthony shipped us more of the V-bottom plates that
Good, okay.
were made for the assay. So we have plenty of those.
Oh, good.
Oh, so yeah, that's good. We also got a standard curve and matrix files because that likely was the reason that our standard curve didn't look the way that it should have, because they're only supposed to be, they're given in little vials with solids, and then you dissolve them in I think it was the assay buffer, and then you have it prepared. That was only supposed to be prepared for up to a month, and ours is prepared for give or take over a month. So they were saying that would cause issues, so they sent us new standard curve and matrix files, and then also they're sending us new B cell panel kit and antivirus kit, which means that then I can do up to 4 more demos, because right now I have all new reagents except for the beads. They didn't send us new beads because that's the expensive part. But I have about 30 microliters left of all the different beads. So I can do 1 more demo for the B cell panel, 1 more demo for the virus panel, and then I could definitely do 1 more demo once we get the new kits for each of the kits. So I have 4 shots to get the demo to look right, basically.
So the thing they're sending is more plates and more what? Antibody cocktails?
No, it's more of the assay buffer, the wash buffer, the detection antibody, the matrix, and the standard curve. And then they are sending new full kits, but those are not in yet. We just got in all the plates and the standards and the reagents.
So the full kits contain, like you said, the expensive part is the beads?
Yes.
All right.
So that's good. So
now the beads, as I think of it, the beads there's 2 mixes of beads, right?
Yes.
There's just A beads, which have,
Well, actually, the A and B beads are mixed together. The 2 sets of beads are the B cell panel beads and the antivirus panel beads.
Oh, right. Okay. A and B are mixed together, right? Yeah. And one is fluorescent one way and one is fluorescent the other?
Yes. PE and APC.
Okay. So that's how you distinguish them, and you get your 2 peaks.
Yep.
Yeah, that's it. And then they got different sizes, so they can only do, so that's why they multiplex like that. Okay. Yep. So they send you the mixture of A and B beads for this panel, like B cell panel, and this panel for virus panel.
Right.
And is that what they're going to send again?
Right. Yes, they are. They're sending the full kit. So it will have all the reagents, all the new beads, everything, just like what we got for free. They're resending us that. And also the B cell panel will not have BAF in it.
Oh, good.
So we won't have to worry about that. So that's a
plus.
plus.
They don't have the BAF beads.
Right. So it won't have the BAF beads. And so it should be good.
And how many, the beads, I forget, how many do you use per well?
25 microliters.
25, okay, so beads are 20, and that's the initial start, yes. Or maybe it's not the start, but 25 microliters.
Yes.
Beads. And how many beads, what's the volume that they're sending?
I don't know. It's enough for about 100 and I think it's 15 samples or something.
So
like
about
that.
2.5 mils.
Yeah, something like that.
And
I can check the exact volume.
That'll be enough for 100 aliquots of 25 microliters. So they're sending a bottle of A and B beads for B cell, and another bottle of A and B beads for virus.
Yes.
And that's all for free?
Yeah.
All right, that's a good deal.
Because basically what happened is when we did the demo on Monday, it didn't work, and it wasn't my fault. He was there the whole time. So it was kind of his fault. And we used then on Tuesday, they were supposed to send us the new reagents and stuff so that we could do another practice. Well, they didn't come in. COVID. So then we had to use the rest of my virus panels. Then he's like, well, now I'm gonna have to send you both of them for free. And
There
really,
you go.
originally we were supposed to get a 6-plex. He was sending just like a little demo 6-plex, and that's what we were supposed to use for when he was here. Well, that never came. So we had to use my kit. So it actually worked out great because then we got 2 free kits.
So remind me again, the virus panel contains, I think we know, beta, is it interferon beta?
Yeah, beta,
Yes.
gamma.
Beta, gamma,
Right.
what else?
I'm gonna show you the.
Maybe IL-12 or TNF, IL-1.
So the A beads are interferon gamma, CXCL1, TNF alpha.
This is a virus?
Yes.
Okay, go ahead.
CCL2, IL-12.
What does he say? What is it? CL, what is it?
I'll send you this.
No, I'm just wondering if it
Yeah,
can.
but I don't see interferon though. Interferon
It's in-
beta. Get that? Oh, interferon alpha. Oh,
And here's beta.
oh, good. That scared me because that's really what we want.
Yeah, this is the B beads.
Hmm.
The B beads are, oh, right, because you showed the A beads.
Yeah.
So I'm looking at the things you're really interested in, and IL-1 is interesting, I guess. IL-6 is definitely interesting for the, so that's in the B panel.
Yeah, this is the B beads for that kit.
I'm just trying to think of the ones you really care about, but anyway, but they're sending the kit, and then all these coated with beads with the antibodies to these will be there. And then the B cell panel, what does it contain again, sort of?
The B cell panel.
There's a lot of things we're just not that interested in here.
Yeah.
But that's okay. We'll get those for free.
Let me grab.
If
I'm gonna grab the sheet for the B cell panel because I don't know off the top of my head all of them that are in there. I'll be right
I'm
back.
just worried it'll be like most people in papers. They publish things they can do that are easy but not interesting. So these beads are the same thing. Oh, look, the IL-12 worked, or something that we're not in. IL-6 works so well. Yeah, but we're not interested in that. I mean, if we could do that. So now they're going to. We want to have interferon beta work. Of course, now interferon beta we assume isn't going to work anyway. So we got to.
Interferon beta though, we have the ELISA for that too.
Yes, right. So we're already assuming interferon beta won't be detected. So we sort of but we don't want just the simple things that we're not interested in to work. But we'll see. So that's good. I think I understand it now. I've kind of got it kind of up to date as far as why things might not work and the low number of beads.
Yeah, I'll show you. So I did it. I looked at everything on FlowJo too, and I'll show you what it looked like last time we did it. Do you see how few beads there are?
Yeah.
Like I could barely get any separation.
Oh, you mean this is from last time, not this time?
No, this is from this time. This is from this time. So look at this, right?
Yeah.
Well, there's something more. There's something worse than that. That the barely is the huge variation. Is this like one sample?
This is one sample.
I mean, what's this? There's the one sample binds from 0 to infinity. I mean, what kind of result is that?
What?
What do you mean?
I mean, it goes from, not 0 to infinity, but it goes from.
No, each one is a different cytokine. It's a different. Yeah.
No, I'm saying, no. Let's take interferon gamma. This vertical spread, some beads bind 10 to the -2, some beads bind to 10 to the 2. I mean, you put a sample in with a certain amount of interferon gamma, and you get, and what's the result? Well, somewhere.
I don't think it's binding though. I don't think that's what this is. I think this is a signal of PE.
What?
I think it's the PE signal.
It is a
I don't
PE.
think this is. I don't think it's.
That's what he's saying. That how could one sample then?
Wait a minute, just a second. I see APC and PE. What's PE?
PE is just used to separate out the beads, but it's supposed to look like this. It's supposed to, because I showed this to
But
Anthony.
what is PE? What's labeled with PE?
The beads are. The PE is the whole,
Thicken.
it's like the main signal. So that gets all the beads are coded in PE, and then APC is used to separate the different cytokines because they all have various expression of APC. From what I understand, that's how it works. Because we use streptavidin PE at the last step. I add that streptavidin PE for 30 minutes, and then I wash and resuspend and run the samples.
Yeah, there's a problem here because the last step, the antibody cocktail you put in is PE, obviously because you streptavidin PE is the last step.
Yeah.
So the antibody, secondary antibody, is hanging out there, and it's going to bind streptavidin, I guess, right?
Yeah.
Or
It
right,
like completes the sandwich, Eliza.
right. It's a sandwich ELISA, and it's labeled PE on this bead, and the more each one of the dots represents a bead.
Yeah.
So some beads are very strong PE, and some are low.
I see. I don't know though. I thought that was, he didn't say that there was anything wrong with the way that looked. Because I also adjusted the axes so that we could get some separation. So I don't know. I guess I can ask again if that's an ing of some sort. Last time I got the same type of thing, but look at how many more beads I had. Like, look at how many A beads I had, and look at how much
Can you
better.
show me some results there.
What was that?
Oh, I see. You're showing it. Okay. Let me
This is the time that I did it like a month ago. Look at how much better it looked.
Right.
Right.
That's right. It's like,
What's the number beneath what's the number down below?
What number? This?
No, the 12.7 at the beginning and
This is
31.1.
the frequency of the parent gate, isn't it?
well, so the question is it the mean intensity? I think it's the mean intensity, right? I would think it's the mean intensity
these were the
of the
frequencies.
PE.
Right, it looks like it. That's why I was asked. This is a good sample. Because IL-4 we know is low. And sure
Right.
enough, I see a cluster of beads with the
Right.
down at the bottom, sort of a low number, a low value. And sure enough, the value beneath there, if it's the mean, is low, 12.7. Versus I look at TNF, which we know is high, and its beats are shifted up, and the
Right.
numbers shifted up at 31.
Right. Yeah.
Now, the thing I'm having a problem with here is that still the result for each one is roughly 0 to infinity. I mean, some are like 1 to infinity minus 1, and others are like 0 to infinity minus 10. But whatever, it's like, why is it? Well, this would be unacceptable in a regular assay that there's such a spread in the result. That's I think the vertical spread is how much streptavidin PE that bound to the antibody that's secondary antibody that's bound to this cytokine that's bound to the bead, so that kind of sandwich ELISA. And there's such a huge variation.
I don't,
Yeah.
I think that, I mean, when I asked Anthony about if this looked like what I should get, he was like, well, we don't usually use FlowJo because that's not the way that you're supposed to do the analysis.
Oh, its program gave the same result.
But yeah, but it's not, I guess this is what it's supposed to end up like. It's not supposed to be little dots here. It's supposed to be stretched out. I think it even had a picture of it in the manual. And this looked right.
Everybody says this. I know it's very consistent that this thing gives a broad, that the binding reaction is not saturated at some level or another. There's limitations that prevent the steps from going to completion.
Mhm.
And then you get a bunch of low results, and some bind better and you get high results. Some beads are very bright in the end. And why anybody tolerates a range, okay, it's not minus infinity or plus infinity. It's tenfold. Like nobody could tolerate like interference, like TNF alpha ranges from like, I'm gonna guess here, like ranges from 10 to 10,000. And so we're gonna get the average. That doesn't make sense that somebody would have an assay with such a broad range of a readout result. Maybe Anthony's been looking at it so long, says, well, I don't know. The point I'm making is somewhere way, way back, something is not done optimally, and therefore it carries through to the end where you get some that are very low binding or very low beads that are now saying there's I didn't get exposed very much to this, to some reagent along the line here. Probably the first step. Although
Probably with the sample and the beads when it's incubating for 2 hours.
right. What I'm thinking of is
That's probably what it is.
that some step needs to be more uniform.
Yeah.
Like mixing during those 2 hours or exposure to make sure all the beads are the same, see the same amount of, let's say, shall we say, cytokine in the mix, in the original mixture or something like that.
Yeah.
And then every other step is also done to completion so that you don't get this range.
Yeah.
I mean, doesn't Anthony realize that that's a problem?
I mean, that's why he wanted
I
us
can't tell about Anthony.
different
What
shakers.
kind of idiot is he? He's
When
gone, but okay.
When we showed him Chang Ming's shaker, he was like, oh, no, that's not going to be good. And
No,
he's
I
like,
know.
oh, the vortex shaker is going to work. But I didn't want to, I mean, I know that I obviously know a lot less than him, but when I put a plate of water onto the vortex shaker,
Yeah,
I
no.
could see that it was vortexing. It wasn't mixing. It was pelleting, like it would pellet things if there was anything to pellet. You could see that it was kind of vortexing. So I think David and I kind of agreed that wasn't going to work with the vortex shaker. You need like a plate shaker that's actually going to shake your plate more and not just vortex everything to a pellet. And Chang Ming's behind his desk did okay. I mean, it did better than the vortex shaker, but I still think I think you're right that it's not really getting mixed in because it's in that B bottom plate. And so it's really not mixing enough because it's just going like this a little.
Yeah.
Here's what I think.
I agree. Yeah.
I think I know the solution to all this. The V bottom plate. How many microliters of serum do you put in?
25 microliters of the serum.
25, okay. So the B bottom plate has this one step where it's useful is at the beginning, because you got how many microliters of beads?
25 microliters.
25. I'm not even sure it's useful. But in any event, 25 of the beads and 25 of the sample. So it's
and
only
then 25 of the assay buffer. So it's 75 microliters total in the buffer.
Yeah, that's what I was saying. So at the first step,
Yes.
all that goes together?
Yep.
Okay, assay buffer. Right. What's in the assay buffer?
I don't know. It doesn't tell us.
It probably promotes binding. It's probably just a buffer that sets the pH so that the antigen and the cytokine can optimally bind. If you get too far pH or low, then the charge changes, the antigen won't bind. So probably sets the pH so that the cytokines can bind optimally. But other than that first step, and I'm not even sure of that, these V bottom plates are deleterious as they prevent everything from being homogeneous.
But I need them for the wash steps. That's why I need them, because I centrifuge and then I wash and then I centrifuge again, wash, resuspend, let it sit, centrifuge again, wash. So it's for the wash steps. Because then when I centrifuge, then I get the pellet at the bottom of the V bottom plate. and then I can do everything from there. That's the only reason that I need them, really.
Yeah.
But the thing is
how much do you wash with?
I wash with 200 microliters of wash
Oh,
butter.
that's a lot. That's almost a whole well.
But really, I was thinking, so with the if I didn't use the V-bottom plate, I could at the beginning start with a flat bottom plate and then let it incubate like that on the shaker and the flat bottom plate, and then transfer from there to a V-bottom, centrifuge, let the pellet form, wash, centrifuge, resuspend, and then when I resuspend, I just suck up the volume, put it back in a flat bottom plate, let it incubate again on the shaker. You know what I'm saying? So I could start.
No, I see exactly what you're saying. The thing I'm thinking of is, you know, in this case, if it's 75 microliters, now you don't want to lose all the fluid, but the flat bottom, see, the other thing is evaporation, but I guess you could keep that down. A flat bottom plate will allow things to at least mix.
Yeah.
You could do that a little bit with a pipette. What I'm thinking of is a U bottom plate. You know, we use that a lot. Little pellets of cells, you know, 10, like we just did it about last night. We do doing 10,000 cells. Well, we don't do that, but we to do RNA. A U bottom plate sort of collects it at the bottom, you know, on a pellet.
Yeah.
And if it's 200 microliters, you can take out 190 of it without disturbing the bottom.
Yeah.
And then you wash with that. So, but the U bottom plate is sort of a nice in between flat and V.
Yeah,
because it will allow things to pellet, but it will also not restrict things from moving that much. I mean, they can move around a little bit. In fact, that's what you're saying is it'll make them move too much, and then you can't pellet, you can't wash them. But I don't think it'll be that bad, you know. And then at the end, they work better. Like we just said, they're better at mixing, and they also pellet. That's why they make you.
Right.
Like somebody thought of a U bottom plate, you know, because they want it to be sort of not so crowded as a V and not so uncrowded as a flat, you know. So
I don't understand why they would recommend using. Well, I guess they first recommend the filter plate, but then they're like, oh, you can use a V bottom plate. But obviously, the B deal.
They have a lot of people in this world have a limited scope of knowledge.
It's
you know, they just don't think things through. Yeah. I've noticed that they just can't imagine something new or something's not there, so they just don't understand how things work. You know, I'm not saying Anthony's dumb, but he's trained and he's in this groove that is trained, and there's grooves all over the place, but he's stuck down in this one groove. And he doesn't know how to get to this other groove that's right next to him, which is a U bottom plate groove.
I feel like that would definitely be something, because I mean he literally did one of the plates, which made me feel better because it still didn't work. So I knew it wasn't me. I'm like, well, you're supposed to do the extra, and it still didn't work. So at least I know that I'm not just, you know, doing something wrong.
Now, the one thing that's interesting is if we use a U bottom plate, we have to get it coated. So, you know, because you said something like things stick.
Right. They're not, the plates that we got aren't specific coated plates for this assay. They're just made out of the material that doesn't bind.
Polypropylene.
Yeah. So it seems
the difference
like
between polystyrene and polypropylene physically is polystyrene is flexible, you know, so those are plates at the end. Polypropylene is not flexible, you know, so you can't, you know, they're the hard plates. So is the V bottom a hard plate? Or
no, it's the one you can move.
What?
It's the movable one.
I mean, you can twist it.
Yeah.
But that's not polypropylene, I don't think.
Well, then I could have had them mixed up. I'm sorry.
Yeah, I mean, no, it's okay. Like that's polystyrene. I believe that's right.
Okay.
You know, some plastic, you know, around your house, some plastic you can move. Plastics are interesting. I'm thinking of some plastics like a handle of a coffee pot is hard plastic.
Yeah.
Versus the shrink wrap, you know, like saran wrap is a flexible plastic. And, you know, and then there's all the things in between. But I don't know. sensing the flexible plastic does stick. I mean, that's why you put,
I'm gonna go grab it quick. I'll go grab one of them.
the polystyrene
Yeah.
shrink wrap, like you wrap your food in, it also sticks. They even like that, right? I thought it was electrostatic charge. Well, it is. If you look at the molecular basis way down there, there's styrene and propylene, down there. And styrene is, if you looked at it carefully, it's probably got an O molecule with double bonds sticking up.
Polypropylene.
Propylene.
Polypropylene?
Yeah.
Is the right one?
Yep.
All right. Well, they can make it slightly flexible. They can
So
variation,
that's what we need. So we could bottom plates, and then I could.
Here is almost polypropylene because it's slightly flexible, but not very much. But polystyrene is, and this is, I know there's lots of kinds of plastic, but this is probably polypropylene. Doesn't flex too much. But polystyrene are those ones that flex. Well, maybe it could be, anyway, okay. You understand.
Yeah, so if we could get U-bottom plates that are correct, and then I was thinking of running another demo on Monday probably. And the other thing was,
I vote for U-bottom.
Okay, yeah, that sounds good to me.
From beginning to end, it'll solve all the little. I don't like this thing where reactions aren't complete. You want every reaction to go to completeness. So there's not like a bead that didn't see anything, which you can see there are some, versus there's a bead that saw everything. I mean, it just ain't make it. And every step after that, drive it to completion. Whatever it takes, time, agitation, temperature, whatever it takes to make it so that the beads end up as a tight little badge.
Yeah. So the other thing is that Anthony was saying that it could be something where this kid doesn't do as well on symphony. I don't know. So I was thinking about running 2 plates.
Well, if it's a symphony, can we run with the LSR2?
We can run with the Fortessa.
Yeah.
So I was planning on running one assay with Symphony and one with the Fortessa, and then looking at the difference and see if there's anything that would make any difference whatsoever. Just before, you may as well try it, and if it looks like they both are about the same, then I'll use the Symphony. If not, then I'll use the Fortessa. So. That's kind of that's another thing that I was planning on.
Right.
I don't see why that would even come up, because
Anthony said that he's never used these kits on the Symphony, and there isn't any, like, on the BioLegend website for these kits. There's a section that says instrument setup. The Symphony's not on there.
What about the one? What's the other one?
The Attune, I could use.
Attune, yeah. Can you use the Attune?
But the Attune, I guess they were saying the Attune on the core is like really, really picky, kind of finicky machine. It's not as good as the Fortessa, I guess.
Right.
If I only need a few amount of lasers, I may as well just use the Fortessa.
It's really just in 2 lasers.
I do, so I may as well use the Fortessa instead of yeah. So I was gonna try the Symphony and the Fortessa and decide from there based on.
But what ones are on their list?
The Fortessa and the Attune.
The Fortessa and the Attune?
Yeah. And I think the Canto might be actually too.
Yeah, because Attune has this plate. There's a plate format platform, but I don't know about Fortessa. Fortessa, I don't know if they can.
The Attune is specially designed for plates.
It has a plate reader again, just like the Symphony does.
The Attune?
Yeah, it does.
Oh yeah, no, I mean that's what it really likes is the plate.
Oh,
right.
The Attune is made for plates.
Right.
Everything else is made for plates or tubes.
Okay.
So I would think, if anything, the Attune, it has, like I recall, because we bought the Attune, we were going to arrange, right, Richard? You wrote the grant.
Right.
We bought everything that's down there now. So the thing is the Attune had a better agitation or a step for, that was its big
Right.
strength. They said,
That's
no,
right.
it's low
Okay.
thing, but better. They had 96-12 plates because you stick them in and you can let it go for as long as you want. Let it
Right.
start, even do a real time reaction. But the one thing it was good at was sample resuspension before it sampled them. And I think that's well, I don't know whether it goes up and down more or easier or more
Okay.
vigorously, but mixing was one of the big advantages of the attune.
Okay.
So I think the attune might be something to look into.
Okay, so maybe I should compare the Fortessa and Attune instead then.
Right.
Yeah, test the
I
attune.
guess if I want to use.
I don't know for Tessa can read the plate though. So
But so we kind of had ruled out, at least Anthony and I and Sagar and Raul had talked about using the plate reader, and they kind of thought that it wasn't worth the risk of using the plate reader, because if something goes wrong, you lose everything. And I guess that Raul has had that happen to him multiple times with the plate reader on the attune, where it sucks up the sample, nothing reads, and your sample's gone.
I see.
That's it. So we had kind of decided it's not worth the risk.
I
I'd rather
see.
just use the tubes
Manually.
and do it
Yeah.
manually,
All right.
just in case,
That's good.
because I don't want to lose any samples.
Yeah. No, that's good. I agree.
Right, as I recall,
With
I
the
remember the attune clogging.
in fact,
Because
the
it's got a
71
different kind. It doesn't have the same
Yes.
pressure or suction mechanism.
Right. So
So
the
it's prone to
71
clog.
sample, the same sample with the fax, we lost the sample with the T-BAT set,
Yeah.
but that was Symphony.
Okay.
Yeah. So
Yeah. Yeah. So that's the other thing. So I will have asked David to order the U-bottom plates for my next demo. I'm planning to do 2 plates. I will run one on the Fortessa and one on, do you guys think I should use the Attune or the Symphony for tubes? Whatever you think
know,
is best.
if not gonna use the plate, then I think for Tessa is fine. Yeah.
Okay, so I'll compare and see if there's any difference in how many beats I get on both the machines. And then assuming that everything goes correctly, now that I have the new standards that are fresh, new reagents and all that, I hope that everything will go correctly. The last thing is just the plate shaker. So I don't know if that's something that we can buy, or I can ask around a bit more. I asked like Andre and Bea's lab down the hall. I knew someone that was in there. I asked them, they don't have one. The people across the hall, I'm not sure exactly who the PI is across from the Ballesteros lab. They don't have a plate shaker either. And then I don't know if there's anyone that you guys know that would have one.
Well, so the thing is, yeah, so I just said, just buy one from Fisher that's 600 something, but on the other hand, that might not shake well.
Okay.
Because I think usually they would shake this way, right? So I think U bottom might work, but not the V bottom. Yeah,
Right.
so in a way, I don't mind to get the plate shaker. But on the other hand, whether it's gonna work well or not, I don't know.
So should I just use the one behind Chang Ming's desk that kind of goes back?
Well, that's not the right one.
No,
Though.
that won't work.
Yeah. So you see, let me share. For example, this is like $660, but I think it would shake this way or this way.
Yeah.
But right, better than just like this.
What I'd probably do is rotate it every 20 minutes or something. If it's this way,
Right.
rotate
Yeah.
it so that everywhere's getting.
Yeah, that's right. So maybe we could maybe read them carefully, make sure it does shake this way, and it does control the speed, and so it can go pretty high, as I know. Here,
Wait, can I look at the, wait, go back down. The first number is 25,000. What's that next number? 800. What is it?
Yeah, I don't know what it is. So that's why I was
I
gonna
think
go
the
down.
first one is time and the second one is like,
Oh, you can, let's see.
I think.
Oh, time and speed,
Yeah.
right? 800 RPM maybe. So let's see what it says.
Well,
Oh yeah, so 150 to 10, 100,000 RPM. Yeah. So what did the BioLegend, did they send the protocol? Do they have, do they specify what's the speed you want to shake it on their protocol?
You know, I don't know. I don't think it did. I think it just said put on plate shaker. I'm gonna look though.
Yeah. So
I
maybe,
don't think I paid attention to that since we called
Yeah.
it the Alabama plate shaker because it was
Yeah.
like
hmm,
very funny way of getting all the
Hmm.
taping on top of the vortexing and it's like
Yeah.
arts and crafts. We were joking like, oh, we're doing arts and crafts instead of
yeah, yeah.
right, if you're gonna do Alabama plate shake, then you need duct tape.
we did use duct tape. That is what we used. We duct
Oh,
taped
really?
everything
Yeah,
on there.
That's how I fix my mirror in my car
Uh,
and my fender.
Yeah. All right. So yeah, so like this one's a little bit better. It can go somewhat higher.
yeah.
So kind of look at their
Thing that for a while, like, and I'm not even sure the heat, 37 degrees or, but let it sort of, pry off some of the antibody that's stuck to, that's non-specifically stuck to the bead. Right.
Yeah,
So
okay.
that's the step. That
Yep.
background is high. That background
Yeah.
is the same as the signal.
Yeah.
That's unacceptable. Nobody wants it back. You see the background we
for
like
sure.
in ELISA. We get a signal of 2 and the background is 0.01. We want this background to be 1/100th of the signal, not about the same. That's ridiculous. That's probably why, possibly why you get this big variation. Is
Right. Probably.
some beads had got soaked up a lot of background, some didn't. It's a background assay, and then you got a little bit of signal that shifts things up and down. That's terrible. That people don't focus on the background. There's so many things about this that sound like they haven't been thought through very well.
I think the steps that we're changing will make a difference.
But don't forget the background.
Yeah, no, I
Change
agree
that
with you.
one.
Yeah, that's a big change too. So hopefully, next week I can do another demo with the changes that we talked about, and then I will let you know how it goes. We can go through everything, and hopefully, fingers crossed, it works out great, and then plan a time to actually do the real experiment. So, and thank you again so much for all your help and everything. Really appreciate it. So,
I feel like we're behind on this.
well, I kind of felt like at least, I'd rather it take a little longer and know that we're going to get it to work.
No, you don't have to thank me because, because we're behind. I'm saying I'm behind on of course I had to see some data, but the thing is I feel like I'm behind on helping you because all these things we knew, but when you say them, says, oh, that too. We were just like, I got a list of 4 things here that are key points that I should have told you, but of course I didn't know I needed to tell you, bring it up. For example, let's just take flow cytometry. I put down, I'll just say this, I wrote it down. There's 3 things that determine which flow cytometry to use. One is being able to resuspend. Who does that best? 2 is sample size and suction. What can you start with? What can you stop with? So if you can't get it, if you resuspend, but you cannot get it all in some settles, then you don't have any beads. But third, and I forgot about it, but most important, is the hydraulics of the particular fax machine you're using. Some hydraulics have pressure they blow into tubes. Some, but if you don't have a tube,
Mhm.
you know, that's not the way things work at all, because there is
Would you mind sending me that list of
Yeah, I'm going to send it to you.
different
But I'm saying
things?
hydraulics, and beyond, in addition, and beyond hydraulics is what are we talking about here? A tube uses completely different hydraulics than a plate. A tube works on the principle of positive pressure. Uh, Let me see, positive pressure into the tube, I believe, to force it into the nozzle at the bottom. But a plate, of course, can't do that at all. So it sucks. And some of them really do suck, because the sucking mechanism is a negative pressure that I recall in the Attune has two rolling components. You know, they kind of, there's a plastic tube and one thing rolls and it alternates with the other one. It creates a slight vacuum depending on how it's rolling. And then the same thing, I believe, then the sample has to go through these rollers, you know, that is sucking the bit, making the vacuum. I mean, how big, what a bad design. So, you know, then the sample, it was big surprise, the rollers get all jammed up, you know. So, I mean, it's interesting to think of all these things I didn't think about. I should have told you about or discussed with
Oh,
you.
no problem. That's okay.
So, but now the background, I think that came up at the end, but that should be at the beginning, that we got to eliminate background, how to do it. So I'm drawing a little picture of how to get the background down. And
Okay, thank you. Yeah, thanks. I don't want to cut this short, but I'm trying to make it to the GBS event. It ends at 6. Do you
oh
guys
yes,
mind?
by all means,
I'm
yes.
trying to get on I want to get a leadership position eventually, but if I miss all the events, they're probably not going to want me.
Okay.
So
Oh
if
no,
you
I'm
don't
sorry, I
mind
didn't
at all-
mean to
No,
interrupt.
no problem. I'm so grateful for your help and everything, but I do kind of want to try to get there. If that's
Okay, all right,
Thank you so
we can
much.
talk more later.
Okay, yeah. I'm gonna talk to David about the, ordering the U-bottom plates and the shaker, and hopefully if we can get everything next week, I run the
Maybe we should
demo
go to the
and we'll be in
GBS
touch
event.
about it.
Where is it?
It's in Homewood. They're doing like a outside thing at
I
the,
think you should let Catherine go. Catherine,
Oh,
just go. Just
well,
go.
it's in Homewood. I thought it was
but
over in the middle.
it's still going on. It was supposed to be done at like 5:30, but they said that like, everyone's still there. So I'm trying to I think I can still get to it before
All
everyone's
right,
gone.
but don't, be careful.
I will.
Okay.
I won't drive too fast.
Right.
But thank you. Thanks again.
Okay.
All right.
Okay,
See you
thank
later.
well, thank you. That was great.
Okay. Okay.
Okay,
Bye.
all right, see you.
All right. Can you come over to my side? I want to show